A man has a weight of 175 pounds and stands on a platform that weighs 30 pounds. Where exactly is the man? Right here. What is it? It has the weight Wm for the man, and we'll put it 175 pounds. And so we would put right here, the weight of the platform is 30 pounds. Now, determine the total force the man must exert on the bar, A to B, right here. Okay. And the normal reaction he exerts on the platform. So two things is we want the force that the man exerts on the bar. That's a long subscript. We're going to have to shorten that subscript, okay? And then the normal reaction he exerts on the platform. Another force that the man exerts on the platform. Okay, I'm going to shorten up the subscripts on this to tidy it up. But now we have to get into solving this problem. Let's do this. If I said I want you to get a very large free body diagram, I mean the largest free body diagram you can think of. Wouldn't that be like a big free body diagram? And if I did that large free body diagram, how many cables do I cut? Only 2 cables. And so this cable right here is going to have the same tension as that cable because the world is symmetric around the middle of the man, right? If it draws a line. So what we would do is we would do a free body diagram on the whole man platform and we would only have 2 tensions up, the tension in this, and let's call this tension in cable 1, tension in cable 1, they're the same. And we would have the weight of the man, and we would also have the weight of the platform. It really boils down to a dot, a particle, a point. The whole free body diagram just goes down like the previous chapter. So we have 2 T's up, 2 W's down. The sum of the 2 W's would be you do the sum of the forces and the Y equal to 0, and you get that 2 tensions up is equal to the weight of the man plus the weight of the platform. So guess what the tension, or you can calculate, you don't need to guess. We don't want to guess as engineers. We calculate that the tension in the cable is 102.5 pounds. That's 102.5 here and 102.5 there. There's 2 of them. Okay. Now, somebody says, I would like you to tell me what's the tension in this cable that goes from the bar down to the platform. That's a different cable. That's the tension in cable 2. Can you tell me what the tension in that cable is? That goes from the bar up around the pulley down to the platform. Well, you would come in and you'd do a free body diagram of this pulley. True? And that pulley would have T1 up, and it would have 2 T2s. What do you mean T2? Okay, I have to distinguish. One cable is tension 1 and the other cable is tension 2. And so we find that the tension in the second cable is 51.25 pound. We've done a free body diagram of the whole system. We've done a free body diagram of the pulley, one of the pulleys. Okay. We can now do a free body diagram of the bar. Okay. Let me try and draw it over here. Free body diagram of the bar. Okay. So if I draw the free body diagram of the bar, and I will, even though there's symmetry, I'll put the forces on the end. Don't I have a tension in that cable going up and a tension in that cable going up? I do not have the weight of the bar. It's a weightless bar, negligible weight, but I have a hand. And we already talked about what is that man doing? The force that the man exerts on the bar, right? So maybe you want to give it something like, oh, this is my hand force. And each hand, so hand 1, the other hand, they're symmetrical, the hands, and they're pulling down on the bar. Okay, so if we do that, we conclude that each hand exerts a downward force, that's by the illustration, having magnitude of 51.25 pounds, isn't it? That's good. Let's do another free body diagram. Maybe I'll tuck it in right here. Free body diagram of the man. See, we're getting really good at free body diagrams, aren't we? Now, if you isolate the man and you focus on the man, maybe you go ahead and try to draw the man like this. Okay? And you say, I have, if the man is pulling down on the bar, what's the hand force that the bar exerts on the man? Isn't it upward? Isn't this H1? Isn't this H1 to be consistent with the H1 down and the H1 down? I have to be consistent on my free body diagrams, right? So from the perspective of the man, the bar is lifting up on the hand of the man. And the hand of the man is pulling down on the bar. Okay. We don't forget our weight of the man. But that's not all, is it? Because the bottom of the shoe of the man is in contact with the platform. Okay. The novice would say, oh, well, the platform exerts an upward force to support the man, which that upward force is the weight of the man. That's not true, is it? No. Basically, we leave it as an unknown. That's the normal force that the platform exerts on the shoe, the bottom of the shoe of the man. So maybe we call that the normal force at the platform, NP. I'm trying to introduce some symbols that make sense that don't have super long subscripts. Okay, so we just solved for H1. That's 51.25. This one is 51.25. But now I only have one weight of the man and only one force between the bottom of the shoes of the man and the platform. And so this was 175 pounds. Do the sum of the forces in the Y, and you conclude that the normal force between the platform and the man comes in at 72.5 pounds. Let me ask you this. You take a bathroom scale and you put it on the platform and you stand on the bathroom scale. And that's basically going to measure the force between the bottom of the shoe and then the bar or the platform down there. And that scale would show 72.5 pounds. That's what it would show. Okay. All right. Well, at this point, one mother free body diagram, you've solved for everything. Right here. What is the force that the man exerts on the bar? I would say that's the force that a man exerts on the bar is going to be 2 times, because I have 2 hands, two hand forces, and that would be 102.5 pounds. And at this point, I would show it as a direction. I wouldn't use a vector notation. I would use it like this. I would say it's downward directed. The man exerts a force on the bar down, pulling down on the bar. And that would be the answer for one of the parts of the question. And then the other part of the question would be, what is that normal reaction he exerts on the platform? Well, I would say that the force that the man exerts on the platform is the magnitude of 72.5 pounds. And then it's on the platform, and so he's pushing down on the platform, right? Pulling down on the bar and pushing down on the platform, and we would box it and we'd call it quits. I would do the free body diagram of the platform to make sure it's consistent. If it's not consistent, then we have an error and we look for our error. But you will close the loop and you'll just find that it's consistent. Well, I needed to see if I have enough time. I got 6 minutes to change it up. So the weight of the man doesn't change. The weight of the man is the same. The weight of the platform doesn't change. That's still 30 pounds. This is still 175 pounds. But the pulley system changes such that the man, compare. Is the man smiling or not? He's not smiling in this case. All right. The other case, it wasn't so hard. This one, they're not smiling. Okay. So if you come up and you want to do the same thing, what is the force that the man exerts on the bar? Man on the bar, we want to find that. And then the normal force on the platform that he exerts. Well, do the free body diagram of the whole system right here. What is that tension in this cable and the tension in that cable? T1. Pardon? Aren't they the same? Yeah, they're the same. 102.5 pounds. We've done that. We come down here, we do the free body diagram around that pulley. All right, but look, it's 102.5 up, 102.5 up. It's double that, so it's 205 down, isn't it? All right. Then we focus on the free body diagram of the bar. I'm going to try and draw that over here. So it's feeling 102.5 down and 102.5 pounds down on both ends because of the pulling down of this cable. Okay, the hands have to push up this time, don't they? So hand one and hand one are both hands. So I'll just say the hands have to push up. And so right now the total force that the man exerts on the bar is going to be 205 pounds. Better be a strong individual. And it's upward. Each hand has to push up with 102.5. So the total force is 205. Okay, so we solved for that part. You could come in and do the free body diagram of the man. Okay, so the bar is pushing down on each hand of 102.5. Each hand 102.5. We have the weight of the man. The weight of the man is 175. And then we're going to have from the bottom of the shoe up, we have to have this normal reaction at the platform. But now, the platform, if you put a bathroom weight scale between the foot of the man and the platform, it's not registering a measly, 72.5 pounds now. It's going to be registering a whopping 380 pounds. 380 pounds. Yeah. And it's in the same direction that the reaction that the man exerts on the platform is pushing the platform down. He's standing on the platform. So there you go. So you better have some strong knees. Otherwise, the knees are going to buckle, right? That's what's going to happen to the man. I encourage you to spend more time on this problem. Go ahead and do a free body diagram only of the bottom platform to make sure the numbers are consistent. They are. And it's a good problem to understand. Thank you very much for your attention.